Hi everyone, let's see another problem on mathematical induction. So the question is 4 power n minus 3n minus 1 is divisible by 9. So let the given statement be s of n is equals to 4 power n minus 3n minus 1 is divisible by 9. Now we have to prove that this particular number is divisible by 9. So for proving that, what we will do, first we will prove it for n is equals to 1 in step 1. So s of 1 is equals to 4 power 1 minus 3 into 1 minus 1, that is 4 minus 4 is equals to 0. Then 0 is divisible by 9, yes, therefore s of 1 is true. Then assume that s of n is true for n is equals to k. Then 4 power k minus 3k minus 1 is divisible by 9. Let's suppose that this statement is divisible by 9. So from this we have to get the value of 4 power k, so that we can use it for the further substitution. So 4 power k minus 3k minus 1 is equals to 9 into m dash. Means why we are writing it like this means we can use it in order to reduce it as a multiple of 9 or divisible of 9. Okay, so here, yeah, as you can see that 4 power k minus 3k minus 1 is divisible by 9. That means this can be divisible by 9, means 9 into something. This can be written as 9 into something. So let's suppose it as 9 into some m dash, okay, which implies 4k is equals to 9m dash plus 3k plus 1. So to prove that s of n is true for n is equals to k plus 1, okay, s of k plus 1 is equals to 4 power k plus 1 minus 3 into k plus 1 minus 1, which is equals to 4 power k into 4 minus 3 into k minus 3 minus 1. Okay, now 4 power k we got right in the previous step. The same thing we have to substitute over here, that is 9m minus 3k, sorry, plus 3k plus 1 into 4 minus 3k minus 3 minus 1. So now simply just separate it by multiplying it. So 9m into 4m, we can write it as here 4 into 9m, yeah. So 4 into 9m plus 12k plus 4 minus 3k minus 3 minus 1. Okay, so you can simply cancel minus 3 minus 1 and 4. Okay, so 4 minus 4 will be 0. Now here you will be remain with 4 into 9m plus 9k. Okay, so 9 into 4m plus k. Now as you can see that you can write it as 9 into something, right? So you can say that this total number will be divisible by 9. That is 9 into 4m plus k is divisible by 9. Therefore, by the principle of mathematical induction, you can say that the given statement is true. Let's take another example of another problem. Okay, the same divisibility only. Okay, so 3 into 5 power 2n plus 1 plus 2 power 3n plus 1 is divisible by 17. So let's take that statement as s of n is equals to 3 into 5 power 2n plus 1 plus 2 power 3n plus 1 is divisible by 17. So in step 1, as usual, for n is equals to 1 we have to substitute it over here. In this statement n is equals to 1 you have to substitute. You will be getting it as s of 1 value. Okay, so s of 1 is equals to 3 into 5 power 2 into 1 plus 1 plus 2 power 3 into 1 plus 1, which is equals to 3 into 5 power 3 plus 2 power 4, which is equals to 3 into 5 power 3. 5 5 is 25, 25 5 is 125, plus 2 power 4 is 16, which is equals to 391. On multiplying you can check it out, you will be getting the same value. Okay, which can be written as equal to 17 into 23. Okay, so now we are getting it as 17 into 23. So we can say that this number 391 is a multiple of 17, or it is divisible by 17. Okay, so s of 1 is true. Now assume that s of n is true for n is equals to k. So assume that this statement is true for n is equals to k. So s of k is equals to 3 into 5 power 2k plus 1 plus 2 power 3k plus 1. Let 3 into 5 power 2k plus 1 plus 2 power 3k plus 1 is equals to 17m, because it is this whole number is divisible by 17, right? So this complete number is divisible by 17, means this number can be written as 17 into some m or m dash. Okay, yeah. Now we want only this particular number, that is 3 into 5 power 2k plus 1 is equals to 17 into m dash minus 2 into 3 power k plus 1. Okay, so we are getting the value of 3 into 5 power 2k plus 1. Okay, so the only purpose of getting this value is we can use it in further substitution, so that we can write in terms of 17 into product of something when we are checking it for n is equals to k plus 1. So in step 3 we have to prove that s of n is true for n is equals to k plus 1. Now for proving n is equals to k plus 1, just substitute, instead of n you substitute k plus 1. We'll be getting it as 3 into 5 power 2 into k plus 1 plus 1 plus 2 power 3 into k plus 1 plus 1. Okay, so now in short we have the value in terms of 3 into 5 power 2k plus 1. Okay, so what we will do here, we'll be getting it as 2k plus 2, right? So this 2, that will be 5 power 2, you can write it here, over here, and this value separately, so as we can substitute over here. Okay, plus 2 into 3 power k plus 1 into 2 power 3. So because we'll be getting this value as something in terms of 2 power 3k plus 1, so we can remain this value like this, and we can write here separately as 2q. Okay, in short we just want to use this value for further simplification. Okay, so which is equals to 17m minus 2 power 3k plus 1 into 5 square plus 2 power 3k plus 1 into 2q. So now simplifying it, simply multiplying it. So 17m into 5 square minus 2 power 3k plus 1 into 5 square plus 2 power 3k plus 1 into 2 cube. Okay, 5 square is 25. 25 into 2 power 3k plus 1 plus 8 into 2 power 3k plus 1. So 25 minus 25 and 8 will be 17. Okay, minus 17. So just take 17 common, you will be getting it as 25m minus 2 power 3k plus 1. Now as you can see that 17 into something we are getting, that means we can say that this whole number, this complete number, it is divisible by 17. Therefore we can say that s of k plus 1 is also divisible by 17, concluding that s of n is true for all small n belongs to capital N. Thanks for watching. If you have any doubt, please do comment in the comment section. Thank you.